Good afternoon, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hope you're all ready for a wonderful afternoon of organic chemistry with me, Dr. White. Oh, by the way, I'm an organic chemist, so I'm quite biased about this. All right. This semester, you'll learn a lot about me personally. It comes out when I lecture. And therefore, the first thing I should tell you is I have a hearing problem. It's hereditary. I think I've got about 55, 60% hearing loss. If we were face to face, you'd see me with my hearing aids on. But because right up here, I have two big monitors, or actually speakers that are amplified, I don't need to wear these. But still, if you talk softly, or if you talk with an accent, or if you talk softly in an accent, I might have trouble understanding you. I might ask you to repeat it once or twice. Bear with me, that's my problem, not yours. Now, one of the most important things I'm going to teach you today is the following. In my class, in my universe, there's no such thing as a dumb question. I'll say it again. In my class here, anywhere you see me, if we were face to face, if you saw me walking down the hall, you know me, ask questions. Because in my universe, there's no such thing in my class too as a dumb question. It took me till my third year in grad school to learn that lesson. And that was when I was giving a talk in our research group meeting. We had a postdoctoral fellow, someone who already had a PhD, was working for another research group till he gets a full-time or she gets a full-time job. And Dr. Palavin was that person. And I was giving a talk about my research. He asked me a question about what's called a mechanism that we teach to undergrad organic students, chem majors. Here's someone with a PhD. And afterward, I went to him and said, Larry, aren't you embarrassed asking a question like that, that we teach that to undergrads? I said, why should I be embarrassed? I don't know. I didn't know the answer. You taught me it. I know it now. And then I realized you should never, ever be embarrassed asking questions. Therefore, in my class, in my world, there's no such thing as a dumb question. Now, one of the things I've learned in life is, and if you notice, I'm a few months older than most of you, what's left of it. Oh, I should warn you, I have a sense of humor. I use it. Some days are good humor days. Some days, well, we all have to suffer through it. Me too. But hopefully I'll keep those to minimum. But anyways, I have learned that I don't walk on water unless it's frozen. Then even then I stay off it. In other words, if I make a mistake, correct me. I'll try not to, but if I ever say 4 plus 4 is 7, you should all say, no, it's not 7. So always feel comfortable. If I ever make a mistake, correct me. I keep them to minimum, but you'll see when I'm drawing structures once in a while, I'm rushing and I will make a mistake, but it's rare, but still correct me. One of the things I've learned the last 2 years or so is the number of students can't read cursive handwriting. If you can't read cursive, let me know and I'll print everything. But if you can read it and nobody complains, I'll do a mixture of both. And if you can't read my handwriting, ask a question. Now, I'm going to be doing something right now, an experiment. Yes, I experiment. One of the things, Zoom has a big problem at times. The speaker, me, thinks you're seeing something and tells me you're seeing something, but you're not. So what I've developed over the last year and a half since we've gone to Zoom, on Zoom meetings for lectures, is I call it my thumbs up people. And if you can see what I'm writing, or I switch to something like this, remember, I'll ask you, can you see this? Give me a thumbs up. Everybody see the structure on? Thank you. Oh, you guys are already good at it. This is propane. Do not write this down. Do not write this down. But propane, 3 carbons, C is carbon, and 8 hydrogens. This is called the structure. We rarely in organic chemistry use empirical formulas, C3H8. That's totally worthless. But this is propane. By the way, that's the stuff you get into white tanks for your barbecue. Propane. All right, let's go back. Well, let me do this. How many of you are familiar how to get to D2L, which is shorthand for desire to learn? That's ECC, Elgin Community College's learning management system. Are you all familiar with that? Give me a thumbs up or emoji thumbs up, or say yes on chat. All right, I like to go there now because you know how to go there, but I still want to show you some stuff. All right, right now, thumbs up, people. Do you see ECC bookstore mistake on your? All right, one of your colleagues, I forgot who, sent me an email, and the bookstore was saying you have to buy this lab book. I've been teaching 170 at ECC since, wow, 2007, and I've written my own labs, which if we were face-to-face, students don't have to buy the lab book, and you'll be getting them free also. You have to pay for this class. All right. Important things here. There's some stuff on here, who I am. I'm Dr. White. Here's when our meetings are. They're on Zoom. I'll talk more about it. Here's a link here to the meetings. It's also in my syllabus, which I'm going to go over. And then I have office hours Monday and Wednesday on Zoom. And this should be actually 6:15, not 6 o'clock. I'll change that later today. And here's the link to that. Here's my email address, and here's a link to the syllabus. Now, if you look on top, by the way, this picture is from a coil condenser that I used when I was in grad school. And this is fond memories of good times. Grad school was a fun time for me. By the way, I got my bachelor's degree from IIT, Illinois Institute of Technology, and my PhD from Michigan State in synthetic organic chemistry. Now, if we go to content, you'll see I have my syllabus folder. I have links to log in. I have lectures. All my lectures, anything I put on the screen is available to you. Now, if you notice, I have lectures highlighted here, and chapter 2 alkanes, I have both as a Word document and a PDF document. I use Microsoft Word a lot, like always, but I do know some of you don't. And if you're looking at it on a tablet or even your cell phone, you want to look at this, I have PDF files. Anything I put up in a file, I do duplicate Word and PDF. I'll talk about that later today, practice problem answers. And good news, I am a computer power user. I think I started learning spreadsheets back in 83 or 84. Yes, I've been doing it that long. And therefore, all my lectures are on my YouTube channel. I don't know if anybody's seen that. This summer, you can see what I did this summer, but each lecture this semester, I will post within 24 hours, usually less, within about 12 hours on the YouTube channel. So you can go back and look at it again, or if you happen to somehow have to miss some of the lecture or miss more of it, you can see that. And then I also, something I found out, if you notice, I'm a little older than most of you. That's an understatement. Should I tell you? Yeah, I'll tell you this. I got my PhD in organic chemistry in 1977. How many of you were born then? None of you, I'll bet. But anyways, a lot of you don't know about good things in life, like good music, good movies, good books. So there's a list of things. One of my great joys in life, when I was in high school, my senior year, I saw Jimi Hendrix play live in a concert here in Chicago. In fact, the only time he ever played in Chicago. If you don't know who Jimi Hendrix is, that's sad. One of the greatest rock guitarists ever. But anyways, let's go now in there. You can see my syllabus and download it. Let's talk about the syllabus. This is not the most exciting thing, but it's something I want to cover briefly. Thumbs up, people. You see the course syllabus on the screen? Thank you. All right, a couple things. I'm still Dr. White, and I'm an adjunct. Most of the faculty at ECC are adjunct, and you can't be a professor. Back when I was a student, professors always have to have a PhD. That's been changed. Please call me Dr. White. All right, here's my office phone. I can't remember what year I last checked it. It's really a voicemail box. Best way to reach me is email. I check my email twice a day, every day of the week, including Saturday and Sunday. Now, I am teaching also at College of DuPage. I taught there this morning, and I have 4 email accounts: ECC, COD, my personal one, and I consult, so I have a business account. I get routinely, and I'm not talking about spam, real emails that I should look at, anywhere from 10 to 40 a day. So if I miss yours, if you send me one and I don't respond within about 12 to 14 hours, send me a nasty one and say, how come you didn't respond to my email? But I usually check and respond within 24 hours or less to any email you send me. I try and do less. And one thing, I think when I send out stuff from D2L to you, it has a different email address. Use this one, kwhite@elgin.edu. All right, we'll have lectures Monday and Wednesday from 1 to 3:50. I should mention, for many decades, I was a senior research and development manager at major international chemical companies like Axochemy, Hexion, which used to be called Borden Chemical, PPG, and who did I forget? Unichem Chemicals, which was part of Unilever when I worked for them, Birdseye and stuff like that, Lipton Tea Company. And also, I've been teaching for a while because the chemical industry died in Chicago about 2001, thereabouts. This died, went away out of the United States, a lot of it too. But what I'm trying to get at is, I also remember when I was a student, and I've done enough lectures, that after about 50 minutes of sitting, your brain starts shutting down. We will take breaks. No, I'm not going to talk from 1 to 3:50 straight through. That wouldn't help you learn organic chemistry. So what that means is we're going to take a couple of 5-minute breaks. Normally, when I do it face-to-face at ECC, we take 10-minute breaks every 50 minutes, because that gives students time to go to the restroom and also go to the vending machines, which are far enough away that's a good time for them to go there, get some stuff from the vending machines and come back. But since we don't have that, you're at home or wherever you're watching me, we take a couple of 5-minute breaks. I get up to stretch. Normally when I lecture, I'm standing. And when I take a 10-minute break, I sit down and get off my feet. But anyways, we'll take 5-minute breaks. Because I'm not taking 10-minute breaks, we'll end 10 minutes early. All right, here are the links, which are also in D2L to our class. And we have a different link for, and here I got it right, my office hour is 5 to 6:15 tonight and Wednesday night. If you have any questions, come on by. Good news is you don't have to drive to ECC to see me. You can see me online. And here's the link to it right here. By the way, here's the YouTube channel. You can see what I taught last summer and last spring too. I have them, but I'll be putting on each of our lectures on there. All right, again, email is the easiest way to reach me. The following information all faculty are required to put in their syllabus. I'm going to skip it. You can go back and read it at your leisure. All right, lab book. I'll be giving you handouts so you don't have to buy it. As to the, I don't even know if I have, where did I have it here? Don't even have it in there. I forget, is a good reason. Textbook. When I inherited this course, textbook was Organic Chemistry by Harold Hart et al. I got a copy, I think, in that pile right there. And about 3 or 4 years after I was started teaching 170, I asked the students about 2/3 through the semester, how many of you are reading the textbook? Nobody raised their hand. I'm like, whoa, that's not good, until I looked at the test scores, and those were quite good. And I realized, well, I don't get any money back from the publisher for selling their books, and my students are learning from my lectures. Plus, I've done my own practice problems and practice problem answers, which are better than the practice problems in that book and other books. Why have students spend money for something they don't need? So I don't. But if you want, I'm following sort of the layout in Hart's book. By the way, the original author, Harold Hart, Dr. Hart, was a faculty member at Michigan State when I was a grad student. And he was known, one, for being an outstanding organic research chemist, and two, that book, because over the years, he's made a lot of money off that, which that's all right. It's a good book, but you don't need to buy it. You'll need to get into D2L and be able to access the internet, which I think you all have that. All right, attendance. I used to, when we're face-to-face in my syllabus, I'll say if you miss more than 5 lectures, I reserve the right to give you an F, but because of COVID-19 and the pandemic, I've eased up on that. It helps if you come to meetings, the Zoom meeting lectures. If you can't, watch on the YouTube video. I have a thing about behavior policy and mainly cheating. If I catch you cheating on a test, then yes, I know how to put things in an exam, even though you're going to be doing it online, actually at home, to catch students cheating. Dr. White's I can be very sneaky and do that. So don't. There are 2 things that make me mad in life, and I don't like to be mad at all. One is people who lie to me, and the other is students who cheat. I see cheating as a subset of lying. You say, I know this stuff, and you really didn't. So please don't. I have a thing here about behavior. At the other school, I had a problem once years ago. Here, I've never had a problem with student behavior. But if you're doing something that is unacceptable, I'll let you know and tell you to correct it. And if you don't, it'll be dropped from the class, but not dropped, you'll get an F. And I'll write a letter to the dean of students and my dean. And if it's really bad, I'll get you out real quick. And like I said, that's never happened here, but the other school it did, which is why I put this in here. All right, it helps if you do the practice problems. Here I have textbook optional. Do the practice problems before I do this, and I'll talk more about this. All right, listen carefully. Do not say anything now. Do not put it in chat. See me in private or send me an email. If you are a special needs student, and I know I have one already, I have supported the Learning Center since I've been at ECC and special students who have special needs. I don't know if they still use the term, but we used to call these blue card students because you get a blue card. I've already gotten contacted. Any need you need, special need, let me know. I will help you to the fullest because I fully support this. And over the years, I've had a number of special needs students who've done well in my class. And also a lot of other students who've done well in my class. So if you are, and if you have any special needs besides what was in the email I got, let me know and I'll help you out. All right. I should mention at this point, if you haven't guessed by now, long ago, yes, I was a student too, just like you, undergrad and grad school. So I remember that. And one of the things, first of all, I know is what's important to a student? Well, getting a good grade. And let me tell you, I teach by Dr. White's My Golden Rule of Teaching. Whatever I didn't like done to me as a student, I don't do to my students. That's my golden rule. And I'll talk more about some things, what that means in real life. All right. Thumbs up, people. You see grading and evaluation. Thank you. All right. There's going to be 4 one-hour exams. Here are the dates. I stick to this, but if I feel classes could use a little extra time and practice, I may change it a day or two later, a class or two later. But I tend to stick to the schedule. And they're all on Wednesdays. If I ever make a mistake on a test, let me know. I go through test answers the Monday after I give a test on Wednesday, which is our next class. And if I make an error, I correct it, because you should never be penalized for an error I make in grading. And right before the first test, I'll talk a little more about that. All right, there'll be a 2-hour comprehensive exam on Monday, 12/13 during our lecture time. Relax, students do real good on my finals, and we'll learn later. I give extra credit. There'll be 1 extra credit project worth 10 points at the end of the, not at the end, say about, I want to say sometime in November, early November, I'll talk about this. Also, I give extra credit points on tests. Makeup policy. If something happens, let me know. If it's something extreme, and with the pandemic, I've had students who've had situations pop up that were extreme. I'm pretty easy, laid back, but with the pandemic, I've learned more to help students to work out problems. All right, one of the important things is, how do I get a good grade in this class? Well, there are going to be 4 tests. Each one are 100 points, plus usually they're 5 points bonus, but let's say 100 points. The sum of the 3 highest tests count for 300 points, 3 times 100. The final, relax, take a deep breath, is worth 200 points. And then we'll be doing lab reports, which I'll talk more about on Wednesday, which is worth 132 points. You add it all up, it gives 630. Now, I calculate what I call student percentage. I make it a little larger. And your percentage is the sum of the 3 highest of the 4 test scores, plus your final exam points, plus your lab total points. And it's optional if you do the extra credit. Multiply it by 100, divide by 632, and you get a percentage. If your percentage is 90% or higher, you get an A. If you have 80, 89, B, 70, 79, C, 60, 69, D, F less than 59. Now, when I'm face-to-face, historically, I have seen usually about, and the important thing is students who earn it, work at it, study. Usually in my class, I expect, I'm sort of egotistic, I expect you to do this. Usually about 65 to 75% of the students earn A's and the rest B's and a few C's. Rarely do I ever see a D or F if you put in the time to study properly and do the practice problems. So my grading works for my students. Oh, by the way, how many of you heard about me and read about me and ratemyprofessor.com? Give me a thumbs up if you have. Well, I guess not. We'll find out if you did read, if it's true. It is. But anyways, my students do good. And this last summer, I had a phenomenal group, and I hope you're a phenomenal group. And out of 19 students, I had 16 A's, 2 B's, and 1 C, which is quite good for organic chemistry, but something I expect from my students. One thing, I rarely have students drop, but if you have to withdraw, do it through the registration center. I have no hand in the matter. And it's happened twice years ago. That's why I put it in my syllabus where students have stopped showing up for whatever reason. I don't know why. It's happened twice since 2007. Actually, I've been teaching at ECC since 2001. I taught general chemistry until I started teaching organic in 2007. And if you stop handing in labs, tests, and don't take the final, that's not officially withdrawing, I'll give you a grade. Now, if something happens, especially with our pandemic, if you need an incomplete, I had one student who did 2 semesters ago. I'll help you out any way I can. Ooh, I forgot to do something. Everybody see propane? And propane is still CH3, CH2, CH3. And I think I'm going to go for the next 15 minutes to Guinness Book of World Records saying propane the most times. You'll understand why in a little while. All right, on the screen is the course schedule. For those of you who want to look at the learning module, I'm required to do this by the school, but I just go by the chapters and the names I'll teach you called the functional groups. This week we'll go through chapter 1 and 2. Chapter 1 I'll do in 5 minutes. But anyways, chapter 2, next week we'll do chapter 2 and part of chapter 3. There's no class on Labor Day. And then we'll have the rest of the week, chapter 3 and 4. I'll do chapter 4, and then so on. And I keep to the schedule. I've been doing this long enough. I know I can keep to it. And students do well on that. Now, here's the lab. I'm going to talk about the lab on Wednesday. And speaking about talking about, since I was remiss, this is propane. Propane is, don't write this down, CH3, CH2, CH3. Propane, and that's the white stuff, or the stuff in the white tank that you use for your barbecue. It's an organic molecule. I'll talk more about the lab and on Wednesday, and I'll talk more about the schedule here. And you don't need a lab book. Now, at the very end, I have what's called the student agreement. And you need to sign this, and it's in the assignment area of D2L, and upload it. I have it there and also in the syllabus folder. This is your copy. Let me show you an actual one right now. And here's the student agreement. You need to print your name here. And essentially, it's got 2 parts. One is that you've read the syllabus and you understand you're supposed to abide by these policies. And if you fail to do that, you understand that I will do what's in my syllabus. Also, because I'm posting the videos of this lecture on YouTube, I'm asking you to waive your FERPA rights. That's the federal law that gives privacy rights to students. So I can put that video on YouTube, and that, even though your name or voice or image might be in YouTube, you allow me to do that and sign it and date it and upload it to the assignment area of D2L. And please have that done by the first test, or you can't take the first test, you'll get a 0. This allows me to do that, which is your benefit. By the way, I'm not a big YouTube star yet by any means, but people do watch them, but I think not that many. But that helps students out. All right, any questions so far? All right. Oh, let's do it again. Propane, don't write this down, CH3, CH2, CH3. Propane. For those of you who've ever worked on a construction site, that's used also for the heaters in a certain area, along with, as you know, for a barbecue. All right. How many of you have heard organic chemistry is really tough and hard? Give me a thumbs up. It's not, but I'm biased. I'm an organic chemist. But the way I teach it, you will be able to learn it and it won't be that painful. Trust me, I'm an organic chemist. That word, how about trust me, I'm a doctor. I am. But anyways, you'll see if you follow what I recommend, organic chemistry is not that hard. Now, let me ask a quick couple of questions. You can use either thumbs up or your emoji for Zoom, thumbs up, or the other ones too. How many of you are here because you have an undying love for organic chemistry? Give me a thumbs up or raise your hand or whatever. Oh, it's just me. How many of you are planning on getting a degree or PhD in organic chemistry? Oh, it's just me again. Well, guess what? I'm not going to try and convert you to becoming an organic chemist, but I know you've got to take the class. But the question is, why learn organic chemistry? What's the big deal? Well, I'm going to ask all of you to do something, and hopefully it won't be that painful. Touch your hand with your finger. Go like that. Go ahead. It won't hurt, I hope. You're feeling your skin. Guess what? Your skin is made up of organic molecules, and your protein, which is what your skin is, and I'll teach you later on about that, that's organic chemistry. So is what's left of my hair is organic chemistry. Guess what? My shirt, the cotton in there, that's organic chemistry. The dye that makes it red is organic chemistry. Ooh, this is getting serious. Let's see. Your food, I think I'll teach you later on, you know, the 3 major food groups, proteins, carbohydrates, fats, and oils. That's organic chemistry. The water in here, no, that's inorganic, but the plastic bottle, that's organic chemistry. My lenses of my glasses are plastic, and that's organic chemistry. Wow, this is getting serious. Food is organic chemistry. How your stomach breaks down your food to help you keep you alive, that's organic chemistry. My skin is, my shirt is. So isn't it obvious why it's so important to learn organic chemistry? Because somebody said you have to take this class to get into a program or school, and you want to get a good grade. I know that. Now you know that I know that. but I'm going to help you get that good grade if you follow what I recommend you should do. Speaking about things you should do, remember propane is still CH3, CH2, CH3, propane. And that's the stuff in the white tanks for your barbecue. All right, some good news. The way I teach organic chemistry, first of all, I'm going to be real specific. I do not allow on my tests students to use any electronic devices, no calculators whatsoever. What? Well, the math is real hard in this course. For up to about week 16, you have to, or the whole semester, you have to know how to count up or add and subtract up to 4. Also, up to week 15, you have to know how to count up to 10 and know what numbers from 1 to 10 are bigger and smaller than the others. Like you have to know 7 is bigger than 5. Well, later in the semester, you have to know how to count up to 20. And that's the whole math for this class. Remember, you got to know how to add and subtract up to 4. And for now, count up to 10 and know what numbers are greater and smaller from 1 to 10. That sounds good. All right, now, one of the things students have problem with in organic or any chemistry is how do you do good in the chemistry, especially organic. But before I do that, time for me to be obnoxious again, but there's a reason. Propane is still CH3, a carbon with 3 hydrogens, a second carbon with 2 hydrogens, and a third carbon with 3 hydrogens, propane. Now, how do you do good? What do you have to do to get a good grade in organic chemistry? Good question. How do I do that, Dr. White? Well, I have to talk about bicycles. Bicycles? Yep, bicycles. Let's assume you don't know how to ride a bicycle. And being the nice person I am, I give you the best Blu-ray ever made on how to ride a bicycle, instructions how to ride a bicycle. You've got a nice Blu-ray reader and a huge 65-inch or larger high-end LED TV. And for the next month, you watch that Blu-ray how to ride a bicycle. And you do slow motion, back frame, slow motion again, watch the whole thing. So many times you know every frame by heart. What's going to happen the first time you get on a bicycle? If you don't know how to ride, you're going to fall off. But with time and practice, you get to learn how to ride a bicycle well. Organic chemistry is the same thing. You're going to see me doing problems and, oh, it doesn't look too hard. But if you don't practice them, where are you going to fall off? On the test. I don't want that to happen. Oh, by the way, did I tell you I'm a very selfish person? I'm selfish in the way I like good things to happen around me. One of the nice things, the really good things to happen around me is seeing my students earn good grades. And I will be willing to help you any way to help you if you're willing to put the work into to get the best grade you're willing to work for. And that means you got to practice. And that's why I wrote my own practice problems. That's where you fall off. I'll go through some of them in class, and you can always ask questions, because remember, in my class, there's no such thing as a dumb question. But do the practice problems. I don't think any of you are old enough to remember when Michael Jordan was with the Chicago Bulls. Anybody? Nah, I didn't think so. But if you're around here, it was about 95 when Michael Jordan was the best of the best, the very best player in the NBA, National Basketball Association. And if you were around here in Chicagoland, I've spent most of my life living in Chicagoland. I was born here. You would see on the news or in the newspapers every once in a while, they have a story about Michael Jordan. It'd be the same thing. Michael Jordan, always the first on the practice court, always the last off. He was always practicing the hardest. Why? He was the best, the very best, but he still practiced the most. And I think that's what kept him the best. Practice makes perfect. It's true. Anybody getting sick of me writing propane yet? By the way, you can say yes. Propane, CH3, CH2, CH3, propane. All right, couple important things. See this? I've got the fastest mouse wheel finger this side or the other side of the Mississippi River. If you ever want me to go back on a slide, ask. Always feel free to ask questions or ask me to do like something like that. Or if you don't understand a concept, you always feel free to ask, could you explain that again? Because there's no such thing as a dumb question in my class. Now, I haven't done as many times as I'd like to, but I've done a number of times. I'd like to ask you all, hopefully you're not in a car driving somewhere. One semester I had students sometimes have to be driving somewhere and they would be listening on their cell phone to me. But if you're not driving anywhere, operating heavy machinery, close your eyes right now. Can you see the structure of propane? You sort of remember it? Probably yes. If I'd done more, everybody would say yes. You can open your eyes now. What have I done? I have found through teaching and also myself personally as a student that for memorizing, and I'm going to be honest with you, there's a lot of memorization, organic chemistry. That's just part of the nature of organic chemistry, learning it, that flashcards don't work as good as what I've done. What have I done? I have visually and auditorily, saying it out loud, written propane a number of times. And said it, CH3, CH2, CH3. Now, for stuff you have to memorize, like formulas, if you write it down and say it 3 times or 5 times, that's actually it's 5, and you do that twice, it does a lot better putting it into your brain, burning it in there literally, than flashcards. A number of years ago, I had teaching Chem 170, and I gave, this was face-to-face, I gave back the test, and there were these 2 students who were good friends, real good friends, and they came up to me after class, and one of them didn't do so well on this first test, and the other one did quite well, got a very high A. And the second student asked me, Dr. White, what can I do better on my test? I said, did you write things down and say them 5 times? And she said, no. And her friend said, I did, and look at the score I got. And she shared her test. And the second student got the message. I said, you should do that. And I can still remember, she said, but that's a lot of work. And her friend again said, yeah, but I got a good grade. It helps. Well, that student got the message. She did it, and her test score went way up because she did practice that. And by writing it down and saying it 5 times, if you're in a library somewhere quiet, to say it silently, mentally in your head, works. I don't know why. I'm a chemist, not a psychologist, but it works. I'm looking at my list of things to do. All right. An important thing I've seen over the years is students with test anxiety. They take a test, and for some reason, organic chemistry gets some students very anxious. It shouldn't, it's fun. Trust me, I'm an organic chemist. But this Wednesday, at the end of class, I will teach a method I developed years ago, how to eliminate test anxiety. And it works quite well. I've seen students getting F's, D's, and C's who are having test anxiety problems, and I'll talk more about it on Wednesday, go to A students, not only in my class, they've used it in other classes and it works well too. So I'll do that on Wednesday. All right. Any questions so far? Well, I guess not. All right, let's get started on a couple things. I'm going to assume all of you have had chemistry and know what a chemical symbol is. For my class, you should know H is hydrogen, and then you should know sodium, lithium, and potassium. And then these are the alkali metals plus hydrogen, first row of the periodic. Then calcium and magnesium you should know. Then platinum, palladium, and nickel you should know. Then the most important element in the periodic table for me, carbon, then nitrogen, oxygen, sulfur, and then the halogens, let's see, fluorine, chlorine, bromine, and iodine. And this is my periodic table. I mean, gold and silver are nice, but we're not going to use them in organic chemistry. So you should know H is hydrogen. I'm never going to ask that on a test. Na, sodium, Li, lithium, potassium, calcium, magnesium, platinum, palladium, nickel, carbon, nitrogen, oxygen, sulfur, and the halogens, fluorine, chlorine, bromine, iodine. And when I say you should know, when I put that letter down, you should know C is a carbon or H is a hydrogen. And that's my whole periodic table. All right. One of the things you'll learn about organic chemistry is it's taught by what's called functional groups. Certain grouping of atoms and different molecules always react and have similar properties no matter what molecule they're in. You look right over here, there's the door. And you can see another door back here, and you know what a door is. If you go into your house, apartment, or condo, you went through a different door, doesn't probably look like that one, but you know what a door is. Well, same thing for functional groups, where I'm sitting on my office chair, and you know what a chair is and what is its function, whether it looks like this one or one in your kitchen or living room or dining room, but you know what a chair is. And organic chemistry is the same way. And that's everything for chapter 1 in the book. In the book they have where you learn the functional groups, and it doesn't make sense. Does everybody see on their screen chapter 2, introduction? Thank you. Well, guess what time it is? It's time for a break. Let's take a 5-minute break, and I'll see you in 5 minutes. That would be 1:55, and I'm going to get up and stretch. I'll see you in 5 minutes. something I've used for Zoom meetings to get going. I collect unusual things. I got this in high school. I like whistles. Don't ask me why. All right, welcome back. In case you forgot, I'm still Dr. White, and this is still Chem 170. Guess what time it is? It's time for you to begin your journey into my world of organic chemistry, which is really your world of organic chemistry. By the end of the semester, you'll know all about it. And because I've got many, many years experience in the real world of organic chemistry, not just teaching it, but actually in the chemical industry, I'll be able to share a lot of interesting things with you this semester, because organic chemistry is quite exciting. But then again, I'm biased. I should mention my PhD is in synthetic organic chemistry. Synthesis is a fancy word meaning to make. My training is how to make molecules that do things. And part of the ones I have made are molecules that are used for fabric softening, molecules that are used for antimicrobial applications, molecules that hold sand together to make molds to make things like car engines. We'll talk about that during the semester. But first, a public service announcement, personal one from me, Dr. White. With the pandemic, I hope you all have had your shots. Get them. I got mine early April only because there was such a backlog. It took me that long to finally get mine, but I've had it. And when the booster, when I'm available to get the booster, I will. I'm in a high risk group, age, also high blood pressure, which is under control, and I'm not skinny. And by the way, wear a mask too when you're out there. All right, let's talk about organic chemistry. And it's now time to learn about my world of organic chemistry. When we start with organic chemistry, the first thing to learn is what are hydrocarbons? And hydrocarbons, I assume you all know what a molecule is. That's atoms held together by forces we call chemical bonds. And those are molecules with only carbon and hydrogen atoms on it. Now, there's certain things I'm going to ask you to learn and learn definitions. And since none of you can read my mind, every once in a while, I'll be subtle. See how subtle Dr. White can be? What is a hydrocarbon? That's a molecule with only carbon and hydrogen atoms. If you think about a molecule you just saw, propane is a hydrocarbon. Carbon, C, hydrogen, H. And that's all that's in there. In each of these atoms are carbon plus hydrogen. So propane is a hydrocarbon. And if on a test I ask you what's a hydrocarbon, and the answer is a molecule with only carbon and hydrogen atoms. And we'll learn about other ones. Now, don't forget, I have a fast mouse wheel finger. If you ever want me to go back to a slide, ask. I will. Also, don't forget, in my universe, in my class, there's no such thing as a dumb question. So we have hydrocarbons. How many of you have heard about hydrocarbon pollution from cars and other places? And they're talking about molecules with only carbon, hydrogen atoms. A lot of greenhouse gases are hydrocarbons. Now, the slide you see here is available. If you see at the very top, the name of this file is Chapter 2, Alkanes. And this is in the Word document, also PDF in D2L in the lectures folder. So you can download it at your leisure. All right, let's move on. When we talk about hydrocarbons, there's two types. One is saturated, and the other is unsaturated. And it's time for me to be subtle again. I won't always do this, but for definitions, I try to do this. You should know this. Hint. One thing, when I write something, either print or handwrite it, if you can't read what I'm writing, a good question is, what the heck did you write? Or you can phrase it more politely. All right, let's talk about saturated hydrocarbons. Well, hydrocarbon, you just learned, is a molecule with only carbon and hydrogen atoms. Now, what makes it saturated? That's in which all carbon-carbon bonds are single bonds. And that's a saturated hydrocarbon. And propane is an example of that. Now, time out for a little background. That's better. In case you forgot from general chemistry, there are three types of, and I should put on here, covalent chemical bonds, and a single bond, and that involves one pair of electrons being shared between two atoms. This I'll never ask on a test, but in case you forgot, double bond, has two pair of electrons being shared. Between two atoms, and then there's a triple bond. And that's three pair of electrons being shared between two atoms. So there's a single bond, double bond, triple bond. Now, in a saturated hydrocarbon, hold on, before I leave this, everybody got this copied down? All right, nobody's screaming at me, so I can move on. All right, let's go back. A saturated hydrocarbon, since the hydrocarbon has only carbon and hydrogen atoms, and it's in which all carbon-carbon bonds are single bonds. Now, in organic chemistry, a single bond would be one line, and I could write propane like this. And this single line here and here says there's a single bond between this carbon and this carbon. So propane is actually a saturated hydrocarbon. And that means all carbon-carbon bonds are single bonds. Now, the other type of hydrocarbon is unsaturated. Unsaturated hydrocarbon, well, if it's a hydrocarbon, it's a molecule with only carbon and hydrogen atoms, but because it's unsaturated, it contains one or more carbon-carbon multiple bonds. That'd be a carbon-carbon double bond or triple bond. So saturated hydrocarbon, molecule with only carbon hydrogen atoms, which all carbon bonds are single bonds, and unsaturated hydrocarbons are molecules since the hydrocarbon has only carbon hydrogen atoms, but it contains one or more multiple bond, or you can just say contains a double or triple bond. And double bond, we'll learn later, between two carbons is shown by 2 lines. A triple bond is 3 lines. And I'll be teaching that later on. Ooh, that reminds me. How many of you have heard of saturated, unsaturated fats? Give me a thumbs up if you have. A lot of you have. All right. Guess what? I'll teach you later in the semester when we talk about fats and oils, and that's the industry I've worked in, not for food products, but industrial chemicals. But saturated means it only has carbon-carbon single bonds, and unsaturated fat or oil is a molecule that has at least one carbon-carbon double bond. Now, it turns out, well, first of all, do you know who's the greatest organic chemist of them all? Anyone? Mother Nature. Mother Nature is the greatest of all organic chemists, hands down, period, at least in my mind. I know some great organic chemists I'll teach you about, like Victor Grignard, Emil Fischer, and other great organic chemists, but the greatest of them all is Mother Nature. Interesting enough, Mother Nature never did a triple bond. That's something organic chemists came up with. So that's why unsaturated, even though it's unsaturated, you say it should have double or triple carbon-carbon bonds. Mother Nature never did. So when I teach you later on unsaturated fat, it's got carbon-carbon double bonds. So on a test, if I ask you what's a saturated hydrocarbon, here's the molecule, here's the definition. If I ask you what's an unsaturated, here's the definition. Or I could ask on test number 1, what's a hydrocarbon? You should know this. Hint. Now, there's a certain type of saturated hydrocarbon we call the alkanes. And alkanes are acyclic saturated hydrocarbons. Oh, good news. This semester, you're going to learn some really exciting, fancy new words, the definitions that you can impress your friends, neighbors, and loved ones with. And what's acyclic? Well, bicycle, cyclic means circular, we call it a ring. A is the prefix without. And acyclic means a hydrocarbon that's structured that's not in a circle or a ring. Now, I will never ask you on a test, what's an alkane? And when I say that, I mean it. But it's an important definition you should know, because I'll use the terminology in our class. Now, an alkane is an acyclic saturated hydrocarbon. Example of that would be, you know it, propane. Now, you don't have to put in the lines for a bond between the two carbons. I do to keep my structure straight, or they start drooping to the bottom of the page. Don't ask me why, but I do. And this is a saturated hydrocarbon. And notice it's not in a circle or what we call a ring. So this is an alkane. And I will never ask on a test, but years ago I was told by some students that certain entrance exams, like nursing school, ask if you have an alkane with 5 carbons, how many hydrogen? And there's a formula for that. As CnH2n plus 2. Notice in propane, 3 carbons, then is 3. Therefore, there should be 2 times 3 is 6 plus 2, 8. Ooh, 6 plus 2, there is. Don't have to learn this formula for my class, but some other places they might ask you. So I'll show it to you. Now, molecules exist in 3 dimensions, just like you and I. even though I'll write, and let's assume each one of these is a hydrogen, and the center is a carbon. This shows the stereochemistry of the molecule CH4, almost made a mistake. And we call that methane. And carbon has 4 valence electrons. This will never be on a test. And to get its octet 8, it needs 4 more bonds. This, I'll be brainwashing you. How many bonds to carbon? 4. And notice this has 1, 2, 3, 4. And this is methane. The shape of this with the bond angles, this is called tetrahedral. I'll never ask that on a test, but it's an important thing to know. We'll talk about it later in the semester, how it affects the shapes of things, certain molecules. And later on, like your proteins, like your DNA, the tetrahedral geometry of carbon affects that. Now, what are some alkanes? Well, methane. And where do you find methane? That's your natural gas. On a test, I could ask you, give an example of an alkane in your daily life, and you could put down methane, natural gas. Excuse me. If you cook with a gas stove, if you have a furnace in your house, condo, or apartment building, it's going to be heating up the air when it gets cold here come December, January, and February in Chicagoland with methane. That's burned to give off heat. Now, another alkane is ethane. Notice it's a saturated acyclic hydrocarbon, only carbon and hydrogen atoms, carbon-carbon single bond. Now, ethane, the main use I've seen ethane that you might be familiar with is, how many of you have ever seen at some sports event, the athlete, he or she, sprains their ankle or hurts their wrist? And you see the trainer pull out a little silver cylinder with a little knob and spray stuff on the ankle or wrist. All of a sudden, this athlete's doing better. What they're spraying on is liquid ethane and evaporates very quickly at room temperature. When it does that, it takes energy and cools down the surface it was sprayed in much better than putting ice on it. And certain vegetables emit ethane to ripen, and that's used to help keep them ripe or from spoiling. But main thing is the cylinder. But let's look at the third molecule on that list. Oh, look, it's your old friend propane. And propane is an alkane, acyclic saturated hydrocarbon. What's it used for? Your barbecues. That's stuff in the white tank. Now, these are all alkanes. Now, we can also have cycloalkanes. And where's mine? Hold on 1 second. Let me get something or look for something real quick. Be with you in a second. All right. These are models called molecular models. They're more expensive ones, but these work well. In the center is a carbon. Notice it has 4 spokes coming out, each are a bond. If I were to have propane, 3 carbons, notice it's not straight across. In real life, this is how it looks. And it's not in a ring. Now, I'm going to talk about cycloalkanes. Here we have a regular alkane. If I connect the ends together, and this won't be on a test, we call this a ring. This is a 6-membered ring, and Dr. White and Mother Nature love 6-membered rings. They're in your steroids, your hormones, which I'll talk about later near the end of the semester. Now, thumbs up, people. Do y'all see cycloalkanes? Thank you. All right, now, cycloalkanes are saturated hydrocarbon. That means they only have carbon and hydrogen atoms, which carbon atoms are connected together to one another in a cyclic, which we call ring arrangement, like I showed you here. And the general formula, which I'll never ask on a test, but some entrance exams do, is CnH2n. So if I have 6 carbons, I have 12 hydrogens. Now, I will be drawing, I'll teach you later today, how to draw cycloalkanes rings. And on a piece of paper, it looks flat. But turns out rings are not all rings are flat. This is called cyclohexane. Does this look flat? No. This is called the boat chair conformation. And this is the boat. And this is really important to share how your hormones are structured and work in your body. That's organic? Yep. So not all rings are, hold on one second. Let me close a couple of things here. There. Cycloalkanes are hydrocarbons where the carbon atoms are connected and we call a ring, a cyclic arrangement. Again, I'll never ask you on a test what's a cycloalkane, but I will use that terminology and you should understand what I'm talking about. All right, one of the most important things this semester is how to draw organic molecules. And we have what we normally draw as condensed structures for this class. There are different ways of doing things. And this shows how atoms are connected, but does not show carbon-hydrogen bonds. And really, I shouldn't show, but I will, carbon-carbon single bonds. And it's time for Dr. White to brainwash you. Everybody, how many bonds to carbon? 4. There's always 1, 2, 3, 4. 4 bonds, oops, let me fix that finger. 4 bonds to carbon. By the way, I'm ambidextrous, so I can do it both hands at the same time. Actually, I am. I learned how to throw a boomerang to come back with my left hand before I mastered it with my right hand. Don't ask me why, and I used to be able to write equally, but I gave it up years ago, write with both my right and left hand. Not that it mattered, because I'm really right hand dominant. But anyways, there's 4 bonds to carbon. Does this look like it's coming right at you? Uh-oh, bad humor alert. But you should know there are 4 bonds to carbon. That will help you on all my tests. Now, what does that mean? How do you draw propane? Now, this is called the extended, which I rarely will ever do. Everybody see my whiteboard? Thumbs up, people. Thank you. All right, this is propane. But I'm never going to be drawing this, and I hope you don't either, because on a test, it wastes a lot of time. Notice this first carbon. How many hydrogens? Remember, you have to know how to count up to 10 now. 1, 2, 3. So we put the carbon, and to the right, hydrogens subscript 3. Then this carbon right here. How many hydrogens? 1, 2. And the last carbon right here, I have 1, 2, 3. And that's how you draw the condensed formula. Now let's take a look at this. Let's look at carbon number 1. How many bonds to carbon does it have? It has 3 hydrogens plus this bond to the second carbon, 3 plus 1 equal 4. And carbon always has 4 bonds to it. Let's look at this carbon. How many bonds to it? Well, this line right here and this line to that carbon is 2 plus 2 hydrogen, 2 plus 2 equal 4. And the last one, same thing, 3 hydrogens and 1 bond, 3 plus 1 is 4. And this is how we would write propane. Now, one of the things you're going to have to learn how to do is when you draw structures, put in the hydrogens. So let's practice one. I'll do one, and then good news, I share the fun, so you can have fun too. Now, let's look at the first carbon right here. How many bonds does it have? 1. How many bonds to carbon should there be? 4. So 4 minus 1 equals 3. So that has 3 hydrogens. Let's look at the second carbon right here. How many bonds does it have? 1, 2. But it should always have 4. 4 minus 2 equals 2. And that has, we fill in the remainder with 2 hydrogens. And if we look at this carbon right here, it has 1, 2 bonds to it, but there should always be 4 bonds to carbon. 4 minus 2 is 2, so I'm going to have 2 hydrogens. And finally, the last carbon here has 1 bond to it, but it should always have 4. 4 minus 1 means I have to add 3 hydrogens. And I'll clean it up. And this is how you write this molecule with 4 carbons like this. It has a name. It's called butane. And remember, there's always 4 bonds to carbon. 4 bonds to carbon. You're going to hear me say that an enormous amount of time next week or two, because it's important for you to remember that. Very important. Oh, butane. I've heard that name before. How many of you ever seen the little plastic lighters with the liquid in there, or the bigger ones for your barbecue or fireplace? They're called butane lighters. Why are they called butane lighters? Because the liquid inside is that molecule, butane. So I told you organic chemistry is everywhere. Give that evil eye look. Yeah, I can't, this one works better. But anyways, organic chemistry is all around you. By the way, I stole that from SpongeBob. Yes, I still watch cartoons. But remember when he said imagination? The one with Squidward and Patrick in the box. Anyways, I have a photographic memories. But And it's your turn to have some fun. Why don't you all, with that structure I just drew, write in the hydrogens? Why don't you try it? Remember, there's 4 bonds to carbon. And then I'll go over and do it after you finish. And I always try and give everybody enough time to finish. So if you're one of those people who are quicker at this, please be patient. And when you're done, either give me a thumbs up or use the emoji for Zoom, thumbs up. If we were face to face, I'd say when you're done, look up and smile. I see one person done, yay. And I have a lot of smiling students in my class sometimes. Not everybody likes to do that. If I ever do anything that makes you uncomfortable, immediately tell me in private or however. I will apologize because I never try and make students in any way uncomfortable in my class or ever around me. All right, anybody need more time? I think everybody's done. So let's look at the first carbon right here. There's 1 bond to it, 4 minus 1 equals 3. So there are 3 hydrogens. This carbon's right here has 2 bonds. 4 minus 2 is 2. So the remaining 2 bonds will be 2 hydrogens. Same thing here, 2 bonds. So 4 minus 2 is 2. Same thing here. I see 1, 2 bonds. 4 minus 2 is 2. And finally, the last one has 1 bond. 4 minus 1 is 3. So that would be that. And let's rewrite it. And that's how, oh, let's do another one. These are fun. Plus practice helps your grade, which is good. All right, why don't you try this one? Put in all the hydrogens in that molecule. Remember, there's always 4, yes, 4 bonds to carbon. Isn't the math hard in my class? And when you're done, thank you, Joe. Give me a thumbs up. All right, I think everybody's done. Let's do it. All right, the first carbon has 1 bond to it. 4 minus 1 would be 3. Now, this carbon here has 1 bond, same thing. Same thing on this carbon. 1 bond to it, 4 minus 3. Remember, carbon, there's always 4 bonds to carbon. If you find an exception, let me know, and we'll be rich beyond my wildest dreams. My wildest dreams go beyond my own Lamborghini, my own Ferrari, my own fleet of fighter jets to play with, and my own island in the South Pacific. It doesn't happen. There's always 4 bonds to carbon. Now, this carbon here has 1 bond, so guess what? 4 minus 1 is 3. Same thing up here. And this carbon right here has 1 bond to it. So it's going to have 3 hydrogens. All right, let's look at this carbon right here. Notice it has 1, 2, 3 lines to other carbons or 3 bonds. Ooh, 4 minus 3 equals 1. So it has 1 hydrogen. And then let's look at, I'm going to go Technicolor on you, this carbon. How many bonds does it have? 1, 2, 3, 4. 4 minus 4 equals 0. I don't put a hydrogen there. And finally, this last carbon has 1, 2, 4 minus, and let me do something so you don't get confused. Four minus 2 equals 2. And that's how you do it. Let me rewrite it. And that's how you do it. Now, this is an alkane. Remember, alkanes are saturated hydrocarbons. Notice all carbon-carbon bonds are single bonds, and there are only carbon-hydrogen atoms. I see someone gave me a thumbs up. Thank you, Emily. All right, you should practice this, and you'll see in my practice problems for chapter 2, I have you doing this. All right, any questions about this so far? Remember, there's no such thing as a dumb question in my class. Also, see, organic chemistry isn't that painful? It's not. Now, there's something called condensed structures with parentheses, which we won't be using until, I'd say, the 16th week or 15th week of the semester. See board for example, so I better give you an example. That's not the board. Now, organic chemists are lazy. Yes, we are. If there's an easier way to do this, we try and do something easier. Now, if you look at the molecule I just drew, hopefully you all see my whiteboard, there's something that repeats. That's CH2, 1, 2, 3, 4. Now, until we get to larger molecules, when we get into fats and oils, where instead of drawing out 16 CH2s, we'll use parentheses. For small molecules like this, I won't, but you can. Notice there's 1, 2, 3, 4. Another way of writing this is the CH3 at the end, and the repeating unit is CH2. So you put it in parentheses, and to the right subscript, how many times was it repeated? 1, 2, 3, 4. And this would be another way. Both of these ways are the same and correct way of writing that molecule, which we'll learn later on, is called hexane. Now, good news, I have a piece of paper signed by the Board of Regents or President of Board of Regents and the or Board of Trustees and the President of Michigan State University that I understand both of those are correct, otherwise known as my PhD degree. And you can do either. But until we get into fats and oils, I'm going to stay away from this because it's easier for you to see things that way. And my job is to help you learn this. So I'm going to try and do the easier way. Now, one of the important things is how to draw cyclic organic molecules. Now, cycloalkanes, which are cyclic organic molecules, are represented by polygons. I'll never ask you how are cycloalkanes represented. Poly means many, gon side, many-sided things. By the way, don't tell, if you ever meet someone named Polly, don't tell them their name means many. Sad, she passed away about 8 months ago. There was a really nice woman who for many years until she retired was the dean of English, and I don't know what the for Polly Nash. And the first time I met Polly at a party, I was introduced being an organic chemist. I said, "Oh, do you know your name means many?" And she gave me that look like, you know how many 100,000 times I've heard that? And I apologized immediately. But anyways, how do you draw cycloalkanes? I'll never ask you what the rule is, but we don't write them out. The way we do cycloalkanes is each bend in a line is a carbon. Now, this line method can be used for alkanes, acyclic, but I don't, because students get confused real quick when I do that, and that's not going to help you. If you want to, you can. But each intersection of a line is a carbon, but I don't do that. Hydrogens are never shown on a cycloalkane, which I'll also call just a ring. Now, this is one of the rare times you'll see me drawing it out without line method of a ring. So write it down in your diary, dear diary. Dr. White actually wrote out the carbons and hydrogens in a ring. Everybody see that on their screen now, the ring I just draw? Thank you. It has 1, 2, 3, 4, 5, 6 carbons. I will never again write it because we show it by a 6-membered ring. Oh, look, you know how you have a good hair day? Well, today I'm having a good ring drawing day. Sometimes mine aren't as good as this. And if you haven't been doing it as many months as I have, you haven't. Now, this is the way we would draw that. Notice each bend in a line, 1, 2, 3, 4, 5, 6, or you can count the sides, is a carbon. So this has 6 carbons. Now, this carbon at number 1, we don't show the hydrogens, but they're there. How many? Well, there's 2 bonds, 2 minus 4 minus 2, 2 hydrogens, and each one of those. Now, this is called, and I'll teach you later on, cyclohexane, 6-membered rings, and Dr. White and Mother Nature love rings and cyclohexane rings. Now, when you have a 5-carbon ring, you draw a pentagon. We call this still a ring, and notice there are 5 carbons, 5 bends in a line. How many carbons in this ring? Your turn. Remember, every bend in a line is a carbon. Anybody need more time? Okay, let's do it. Every bend in a line is a carbon. So 1, 2, 3, 4. There's 4 carbons in this ring. By the way, you call it a square. No, organic chemists call that a ring. And a 4-membered ring with carbons and other atoms is part of penicillin. So why are you learning this? Well, penicillin, I don't know about you, but it's an important drug doctors can use. And thank you, Joe. Oh, let's do one more. How many carbon atoms in that molecule? Cycloalkane. And no, it's not a triangle. That's a ring. All right, time's up. Put down your pens and pencils, hand in your computer. No, I can't do that. Well, anyways, 1, 2, 3 bends. So this has 3 carbons. You'd call that a triangle. No, organic chemists call that a ring too. Now, one thing I do want to teach you about, which is useful to know, all right, does everybody see on your screen Wikipedia, cyclohexane? Thank you, thumbs up, people. You really helped me out. Now, this is Wikipedia. If you notice right on the right hand, they show different ways of showing cyclohexane. And the upper left-hand corner where my mouse is in, it's just like I did, except they have software. And for my test, I have software that makes these pretty wing. Now, the reason I'm showing you this is, let's talk about Wikipedia. I can only talk about organic chemistry in specific, and I think chemistry too, but I know for sure for organic chemistry, Wikipedia has been so heavily policed over the years by organic chemists. And yes, I have the credentials. If I ask for a change in Wikipedia page on something organic, it's done. That it's been years since I've seen any major or even minor mistake in a posting for organic chemistry. So always feel free to go there if you're looking for something. There's a lot of good stuff in there. Oh, one thing I neglected to talk about, when I see a 5-membered ring, I might be doing a generation gap thing. I always think of the little greenhouses in Monopoly when you're looking at them. By the way, I don't know about you, but when I was little, like in 1st, 2nd grade, and I was sick and my sister was homesick, we played Monopoly. We always cheated. When one person went to the bathroom, the other one stole from the bank. We played cutthroat Monopoly. Anyways, that's how you draw rings. Now, switches off, but I'll use this term, isomers. Those are compounds with the same molecular formula, but different structural formula. That's an isomer. Let's look at an isomer example. Notice the carbon here, I'll call under A. Structure A has 1, 2, 3, 4, 5 carbons, and 6 plus 6, 12 hydrogens. Remember, there's always 4 bonds to carbon. And the structure I have B also has 6 carbons and the same number over here, 12 hydrogens. But A and B are different structures and they're called isomers. A and B, the difference between them are isomers. Now, before we take our break, oh, actually I went over. Oh no. Bad Dr. White. Why don't you take a 5-minute break, come back at 2:51, and we'll continue on. I can get up and stretch again. It happens when you get older, so you don't get leg cramps. I'll see you in 5. Time to start again. Welcome back. A couple things I should mention. First of all, by sometime tomorrow afternoon, hopefully by tomorrow morning, if you look on the Chem 170 YouTube channel, today's lecture, I'll have the videotape up. If you want to go back and look at anything, feel free to. The link to that is in both my syllabus and on the entry page of D2L for Chem 170. And don't forget, there's no such thing as a dumb question ever in my universe. And also, there's 4 bonds to carbon. All right, so isomers are molecules, and I'll never ask on a test what's an isomer, but I will use the terminology throughout the semester because we'll talk about different isomers. And they have the same, here it says molecular, I could also say empirical formula, same number of atoms and types, but different structures like A and B. And A and B have different physical properties, and certain times one isomer in terms of medicine will help you and the other one might do nothing or do serious harm. And I'll explain an example of that later in the semester. All right, now, if you notice the difficulty I just had, I had to say this molecule here was A and this one was B. That's not that scientific. Well, it turns out about turn of the century, 1900, 1905, the governments of the world realized in chemistry, especially organic chemistry, how do they name molecules, organic molecules especially, so you could communicate about organic molecules, and more important, put them in legal documents such as contracts and patents. Well, it turns out this was an important thing, and this is called nomenclature. I'll never ask you on a test what is nomenclature, but nomenclature is a fancy name, meaning the names of things, how to name things. So it's important how to know about the nomenclature of organic compounds. Well, in order to solve this problem, and it was delayed because of World War I, 1914 to 1916, 18. Right after that, give or take a year, 134 countries in the world, and the United States was one of them, signed a treaty which formed an international organization whose sole purpose, main purpose in life, was to develop and oversee nomenclature rules, naming of chemicals. And most of those rules are organic compounds. Now, the name of that organization, the acronym is IUPAC. I think it's just cool to say IUPAC stands for International Union Pure Applied Chemistry. And IUPAC is an organization headquarters in Geneva, Switzerland. Don't you love Google? Everybody see the IUPAC homepage on your screen? Thank you. Who we are, what we do, nomenclature is their important main thing. And for many years before they had their website, about every 10 years, they put out a new book that had all the nomenclature rules that were up to date. And they be given color names. I don't know why they did that. Like green or gold. I think the last one I can remember is gold. And the IUPAC rules, there are a lot of them. The last book I remember they published was something like 3,000 pages of rules. Do I know all of them? No. Do I know the ones in my area that I work in? You better believe it. And throughout the semester, you're going to be learning some IUPAC rules, how to name different types of molecules or different what we call functional group molecules. Relax. I'm going to do it, not throw it all at you at one time. We'll learn it piece by piece, and students learn it in my class if you do the practice. Now, the first important thing are the IUPAC, and I'm never going to ask you what IUPAC means other than think of it meaning the official name, the IUPAC nomenclature for alkanes. Now, what's an alkane? An acyclic hydrocarbon. And if you had the book, here's a table from the book that we used to use, or I still is optional. But guess what? I've made it easier for you. Because really, you don't have to learn all this from this table. What do you do? By the way, I'm subtle. Hint, know these names, and I'll talk about the structures in a second. Oops, I don't have it open yet. All right, does everybody see the alkanes IUPAC names on their screen? Oops. Okay, thank you. All right, these are the IUPAC names. And if you have one carbon, it's called methane. 2 carbons, ethane. Oh, you know, propane has 3 carbons, butane 4, 5, pentane 6, hexane 7, heptane, octane 8, nonane 9, decane 10. Time for Dr. White to be very subtle. When I was in undergrad and grad school too, and when I was taking notes in my 3-ring notebook on the left margin, if I put a couple of stars like this, it meant you better know this. If I put stars in this, you better know it because it's going to be on the test. And I'm putting that down there. Listen carefully. If you don't know this chart, each name and how many carbons, you've just lost 50 points on test number 1. Test number 2 and 3, you've just lost about 35 points. On the final, you've lost about 35% of the points. So I would highly recommend you learn this table. How do you do that? You write down the word methane and the number 1, and you say it silently or out loud. Methane, 1 carbon. Not only do you have to say it, write it. Then you do the same 5 times for ethane. Oh, by now, I think a lot of you know propane has 3 carbons, butane 4, and so on. Again, know this table. Now, important public service announcement from me, the management. You're not going to learn organic chemistry a day or 2 before the test. You aren't. I didn't. I don't think you can. I have yet to find a student who's had a good grade, and I hope you all do. Practice. Today, you should all start learning that test. So by the end of next week, not this week, but the end of next week, you know that table as good as you know your own first name. And I'm going to assume you all know your own first name like that. So practice it. How do we do that? And by the way, if you go to G2L in the lecture folder, this file, both as a Word and a PDF, and it's got the secret name, alkanes, IUPAC names, and number of carbon atoms is there. So let's do one to show you how easy it is, first of all, to learn the name. Pentane, 5 carbons. Pentane, 5 carbons. Pentane, 5 carbons. And I'll just do it once and I'll let you do it the 5th time. Pentane, 5 carbons. Now on a test, I might ask you to do the following. And by the way, I try and have small point questions, not a few large. And the way I do my test, I better do this. Let me finish this. And it'd be 3 points each and say A was draw the structure for pentane. Well, what do? Well, you've learned pentane. How many carbons? 5. It's an alkane. 5 carbons. That's not finished. You have to put in the hydrogens. How many bonds to carbon? 4. And you learn this carbon has 1 bond, 4 minus 1, 3 hydrogens. This carbon has 2 bonds to it, should have 4, 4 minus 2, 2 hydrogens. Same thing here, and same thing there. And that would be the correct answer. But if you don't know that table, you're not going to be able to do this. And this turns out to be an important fundamental thing to know for this semester. In a couple of weeks, you'll know this table being this, like you know your own name. But right now you don't. So practice starting this week and into next week, practice. Start writing these down and saying them. Now you can't make flashcards, but my experience for all except 2 or 3 students, all the years I've been teaching Chem 170, flashcards don't work as well as writing it out and saying it 5 times. Now, notice octane is 8 carbons. So I'm going to let you have some fun too. Today, I'll do this on a test. I'd never do this. Why don't you draw the structure for octane? And when you're done, don't forget, give me a thumbs up or smile. I don't know, I can see your smile. Oh, I do see smiles. Psst, you're learning organic chemistry. It's not that painful. All right, I think everybody's done. So let's do this. Now, if you learn from the table, octane, 8 carbons, and it's an alkane. And let's see, 1, 2, 3, 4, 5, 6, 7, 8. And now I have to put in the hydrogens. Remember, there are 4 bonds to carbon. This first carbon has 1 bond to it, 4 minus 1 would be 3. The second carbon has 2 bonds to it. 4 minus 2 is 2. And same thing here, same thing here, same thing here, same thing here. Once again, same thing. Now, the second carbon has 1 bond to it, 4 minus 1. Remember, there are 4 bonds to carbon. Hold on, I'm going to do this full screen. There's 4 bonds to carbon. This is important. 4 bonds to carbon. The students had to remember that on tests 1, 2, 3, 4 in the final. About 60% of the things I see wrong, they say that can't be right because I don't have 4 bonds to carbon. And the last one has right here, 1 bond, 4 minus 1 would be 3 hydrogens. That's got 1, 2, 3, 4, 5, 6. I did it correctly, 7, 8. Oh, one thing I should point out, back in high school German class, we had a actual teacher who was German from Germany, ooh, profound, and he used to write his 7s this way. That's a lousy 7. That's better. That's the Eastern European way of writing a 7. And when I was in high school, I thought that was the coolest thing in the world. Ever since then, I've been doing that. I can still remember his name. He was a really good teacher. It was Herr Brink, which Herr means Mr., but in German class, we called him Herr Brink, not Mr. Brink. Anyways, this is octane. Hold on a second. Octane. I've heard that name before. Octane. Where have I heard that before? See, nice benefit of having a beard. You can look scholarly by doing this. Octane, oh, gasoline. How many of you have gone to gas station C on the gas pump? They have the octane number. I think most of you have. Back when gasoline was first being sold, about 1905, 1910, and it was pretty crude back then, they found the best gasoline that gave the best results for the car engine of those days, excuse me, was the one that had the highest number of isomers, you know what isomers are, of octane, including that octane. And to this day, they still use that as octane. Oh, guess what time it is? It's time for another public service announcement from your host, me, Dr. White. Now, a number of years ago, I worked for a company, Axo Chemie. It's now called Axo Nobel, but it's an international chemical company. And their largest type of chemicals called nitrogen derivatives, and I'll teach you more about that later in the semester. I was in charge of all product and process development for North America. Pretty impressive. But anyways, I got called into the a meeting with the production manager, person who oversaw the plants, North America, and the VP of Vice President of Marketing and Sales, and said, we just had this gas company. We sold certain additives to gasoline companies or petroleum companies, and they need to roll out this new additive in their product. And we need in 5 weeks, 5 million pounds. Oh my God, that's going to be a lot of work. So I worked with the plant managers, production to get that done. Well, because I went out to some of the petroleum companies that and other products we sold, I got to learn a lot from these people at petroleum companies like Shell, Mobil, BP, back then it was called Standard, about gasoline. And now it's time for me to share something with you. The best gasoline is Shell. It has been for ages, for decades. They have the highest quality, the best additives. Here's Shell, right, almost as good as Mobil. Marathon, I forgot who Marathon buys from, is a good gasoline. BP is the worst. Back in 1980s, it's the worst. It's still the worst. I will not ever put that in my car. I have a Ford Explorer. I've had a couple of Ford Explorers. No way. If you've been following the news like I do about gasoline, about 4 years ago, a BP refinery in Hammond, Indiana, made some gasoline and sold it. They were selling it out of the gas stations by Gary and Hammond, that area, and also in Illinois around there. That was so bad, it destroyed the car engines of about 4,000 cars that they had to pay to be replaced. I will never, ever put BP in a car of mine because it's just not good gas. Use Shell and Mobil, that's very good. And now, one other public service announcement, in case you're not familiar with this, and that will never be on the test, but these are things I know I will share throughout the semester. If you go, everybody see Gas Buddy on your screen? Okay, hold on. Okay, thank you. Let me check. Yep. The URL is www.chicagogasprices.com, and you can put in for different zip codes. Now, if we're in the Elgin area, put in 60123, and here are all the different gas prices in the area. And notice the prices can be high and low. And I live in the Schaumburg area. Again, the prices really have come down recently, but notice you can have a wide spread. By the way, the ones right by Woodfield, which is about 15 minutes from my house, are always the highest because they get people coming from out of state and rip them off. But anyways, this is a great thing. Generally, I can look at where areas I go. I can save up to 10 cents a gallon on or more. So if you ever forget that ChicagoGasPrices.com, it's a good place to go. Okay. See, you're even saving money in my class. Such a deal. And that's octane. And once again, I can't impress enough upon you, you should start learning this chart. And the chart is the IUPAC names for alkanes, which are acyclic saturated hydrocarbons, methane, ethane, propane, butane. Now the chart goes much more higher. It goes up to, I don't know how many thousand. 11 is undecane, 12 is dodecane, and so on. 16 is hexadecane, and so on. But for this class and most things, knowing up to 10 is all you really need to know. And we'll learn later on, there's something called common names for larger molecules, which we also use, and more likely you'll do this. Now, once you've learned this chart, you know for a certain number of carbons, it has this name. Now, let's look at hexane, 6 carbons. When it comes to skills that organic chemists or people learning organic chemists, you should have, there are 2 types of skills. Hint, there's 2 types of questions I can ask for nomenclature on a test. And one is draw the structure, and I give you a name. That's one type of nomenclature question. The other is and just a reminder, if I ever write something, you have no idea what I wrote, ask me. And if I were to ask, give the IUPAC name for, hey, this structure, what do? Well, notice it say alkane. How many carbons are there? Oh, I have to apologize. I tend to use red ink on my whiteboard. I have a writing tablet, which helps me, just like if I were in a classroom, I'd be writing on the board, the whiteboard in the classroom. Because I'm a power user, I found this tablet. Actually, another faculty member told me about it, and I've been using it. If you are colorblind, let me know in private. But if you don't, I'm going to assume you're not red colorblind, or I use blue. I don't like green other than money. But anyways, when I worked in industry on 3 occasions, I had colorblind chemists working for me. And for certain things, they had to have someone assist them because they were red. Most all of them were red, green, colorblind. But on a serious note, if you are, let me know. Well, back to our organic, give the IUPAC. Remember, IUPAC means official name. 1, 2, 3, 4, 5, 6. 6 carbons and alkane. And you learn this table, 6 carbons, hexane. So what's the answer for that? The IUPAC name for this molecule is hexane. And you'd write that down and you get your 3 points. Oh, let me have you try one. Let's see how good your memory is. Give the IUPAC name for this molecule. And when you're done, give me a thumbs up. 3 carbons, hint. Barbecue, hint. All right. How do you do that? You count the carbons. 1, 2, 3. You've learned the chart. I think you might have known the name already, but let's go back. 3 carbons, propane. And that's how you do it. So the answer to question for 3 points, what's the IUPAC name for this molecule? Right here. And the answer is propane. But if you don't know that chart, guess what? You can't do that, and you're going to lose a lot of points on test 1. Did I tell you my fervent dream is to have a class that everybody earns A's? I've come close a couple of times, but hopefully maybe you'll do it. Now, if you don't mind, how many of you are planning on going to nursing school? Can you give me a thumbs up if any of you are? I see a couple. Or how many of you need to get into organic chemistry to get into a program? Probably some of you, most of you do, or you wouldn't be here. Any students in my class to get a high B or an A, and don't get me upset at them, which is rare, but if somebody ticks me off, I'm not going to help them out. But if you get a high B or an A, I write letters of recommendations. I've been doing it long enough that all the nursing schools and some of the other schools in the Midwest know Dr. White and know I write honest letters of recommendation. If a student's not a good student, I will not write a recommendation because it won't help them to tell the school you don't want the student. That's not fair to the student either. Something could have happened that they just had a bad semester. But if you get a high B or A, and I get to know you, and I talk to you a couple of times in Zoom, I write letters of recommendation. And schools like University of Illinois, Chicago Nursing School, the dean there knows me, and other ones like Elmhurst College. In fact, some of them have email me every once in a while and say, can you send more students? Because when they get a letter of recommendation from me, they know they're getting a good student. The other thing is, next time you haven't talked to a nurse or doctor, Ask them what they thought of organic chemistry, and they'll go, I hated it. For some reason, they think it's the hardest thing. Well, I know why. It wasn't taught well. A lot of schools don't teach it well. I hopefully will. I know I do. And they see someone with a high B or an A, and they go, wow, this must be a super person, because that's organic chemistry. And my students, when I write letters of recommendation, most like 99% of the time that'll help them get accepted. So that's another reason, learn that table so you get a good grade. It's called making it relevant to you. So know this table. Now, there's a series of rules for alkanes called the IUPAC nomenclature rules for alkanes, and I've modified from what was originally in the book. I will never ask on a test, what are these rules? I'll say that again. I'll never ask on a test, what are these rules? But I'll expect you to know how to use them. And let's talk about them. First one, the general name for acyclic hydrocarbons is an alkane. I'll never ask that. And the ending, and you'll learn during the semester what I mean by ending, is ANE. Alkanes without branches are named to the according of the number of carbon atoms. That's the table I just showed you. 3 carbons, straight chain, I call it a straight chain alkane, is propane. 8 carbons was octane. 9 is nonane. Now, here's where it gets interesting. Alkanes with branches, the root name is that of the longest continuous chain of carbon atoms. What does that mean? Well, let's take a look at an example. And remember, if there's ever a concept or something you don't know, feel free to ask. Remember, there's always 4 bonds to carbon. So that's how I know how many hydrogens. Oh, by the way, tonight at midnight, I'll be giving speed structure drawing lessons. No, I won't. I'll wait for you all to draw this out. All right, everybody have a copy down? Don't forget, you can always go back. By tomorrow afternoon, I'll have, or earlier, the video will be on YouTube. There's Chem 170 YouTube, so you can always go back, and you can always ask me to stop. I haven't copied it. Now notice that we have something here. It's not all in a straight line like octane. This is called a branch. And we also call this a substituent. And when it's just carbon and hydrogens, we also call it an alkyl group. And on a test, I would ask 3 points each, give the IUPAC for this molecule. Well, how do you do that? The first step is finding the longest chain. And when I talk about a chain, how many of you have ever seen a bicycle chain, or around my neck, I have a jewelry chain? Their links hold together. And you know how you can fold the chain all different ways? Well, in organic molecule, carbon-carbon bonds are the links. That's why we're linking the carbons together. Hydrogens has come along for the ride. So the question is, what's the longest chain? Well, there's only one way to do, start counting. This carbon is bonded to that carbon, 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 is bonded to that carbon. That's one chain. Another chain would be this carbon is bonded to that carbon. Remember the line right here is the link, what we call in the chain, is bonded to this carbon. But now, if you look going down is a line and that carbon. So 1, 2, 3, 4. This chain goes like that. That's another chain. There's one more chain I have to consider. If I start here, 1, 2, 3, 4, 5, 6. So the thing you have to know is there are 3 possible chains. One is 4 carbons, the other is 7 carbons, and the third is 6. And you have to use your high-level math skills in my class, which is the largest number. And time's up, 7. So the longest chain is 7. Now, let me go through again, just to remind you, how did I find out the chains? Remember, carbons bonded to each other are linked together in a chain. This first red carbon is bonded to the second, bonded to the third, bonded to the fourth, bonded to the fifth, sixth, and seventh. That's one chain. Now in green, this carbon is bonded to this carbon, is bonded to this carbon, and is bonded to that. That's 4. Finally, the last chain in blue, this carbon is bonded to this carbon, is bonded to that carbon, to that, to that, and that. If I count each way, one chain has 4, green, my blue chain is 6, and my red chain is 7. So the IUPAC rule is the root name is the longest chain. And I hope you all agree 7 is the largest number. So let me erase some of this. The longest chain is 7. You don't have to do this on a test, but I'm going to show you. This is the longest chain. And I named that by looking at table 7 carbons. If I look at this table, which you're going to learn, hint, big hint, 7 carbons is heptane. So the root name is heptane. Now relax, we're going to practice more of this on Wednesday, because at first this seems really confusing, but after a while, a month or 2 by now, you'll think, oh, that wasn't that hard, but now it is. So you've learned this table, the root name, the longest chain is 7. And I'll be doing more examples. So I'll put down, once I get rid of this, heptane. And that takes care of all the carbons in the red box. Am I done? No, I've got something left over. This right here. And that's called the substituent in an alkyl group. Well, how do I name that? Good news, there are IUPAC rules for that. Let's look at it. Now, we've done step 3, alkanes with branches. And the reason it's called a branch is you look at a tree, you have the trunk and things coming off from it, which we call branches. Now, the root name is the longest name of continuous carbon chain of the carbon atoms. We did that. Now, groups attached to the main chain are called substituents. I'll never ask on a test what's a substituent, but I'll use that terminology. And saturated substituents that contain only carbon and hydrogen are called alkyl groups. And that I'll use a lot. An alkyl group, one way of naming it is take the name of the alkane from that table and drop the A and the ending and add YL. That's confusing. So guess what I've done? All right, there we go. Once in a while, it will happen on a long lecture day like today. Word will hang up and I'll have to close everything and reopen it. So I've got so much going through my computer, even though it's powerful, it gets hung up. All right, when you have a CH3 group bonded to something, everybody see alkyl groups on your chart, on your screen? Thumbs up, people. Thank you. All right, when you have CH3 bonded to something, that's what this line is. It's bonded to a longer chain or later on the ring. We call that a methyl group. When there are 2 carbons attached to a long chain or a ring, we call that ethyl group. When there are 3 carbons, there's 3 possibilities. One of those possibilities I have never encountered in my life as an organic chemist, which means you won't, so I'm not going to teach it to you. But the 2 you will are 3 carbons. The N carbon is bonded, and that's what this line, to the ring. That's called N-propyl, and the N is small, not capitalized, because capitalized N means something else. I'll teach you way down the semester. Now, when you have 3 carbons, and the center carbon of those 3 is bonded to the chain or the ring, we call that isopropyl. And relax, we're going to practice this over the next couple of days. Now, for 4 carbons, there's only 2 useful ones, really. When you have 4 carbons and the N carbon of those 4 is bonded to a ring or a chain, we call that N-butyl. And when we have 4 carbons, 3 carbons are bonded to a center carbon. That center carbon is bonded to a chain or ring. It's called tert-butyl. And I'm a lazy organic chemist, and a lot of times, and I will after next week, just call it T-butyl. Now, these are the alkyl groups. You should know this table just like you know your first name. Write down CH3 in a line, methyl, CH3 in a line, methyl, and say it 5 times. You'll learn it. Same thing for ethyl, N-butyl, N-propyl, isopropyl. Anybody ever hear of isopropyl alcohol? I wonder where it got its name. Well, I'll teach you. And N-butyl and tert-butyl. Now, it's time for you to know I'm really an organic chemist. Dr. White loves T-butyl groups, and I love isopropyl. The other ones too, but T-butyl and isopropyl have been good to me, and I've been good to them. Now, 1 carbon substituent or alkyl group is called methyl. So let's go back to the molecule. What do we have here? CH3. It's bonded to something, that line. Therefore, this is called the methyl group. And in front of the root name, we have the alkyl groups. In this case, we only have one, methyl. So this is methyl heptane. Are we done? No. Now, say I were to send a letter or postcard to you, wherever you're living, your house, your condo, your apartment. I put your name, I put the street name, and your city, town, and your zip code. But I don't put down the number of your house, apartment, or anything. What's the odds the post office will be delivering that to you soon? 0. Would I have time for a quick story? It was better make it real quick. Yeah. When I used to go, I worked for 2 Anglo-Dutch companies, Unichem Chemicals and Axo Chemie. Now they're called something different. I'd go to Europe often, usually 4 or 5 times a year for 2 to 4 weeks at a time. I'd be in different cities. By the way, if you've never been to Amsterdam, oh, you're missing a lot. But anyways, and I got in the habit of each city, I go and buy postcards, and I had a list of family, friends, and all the people who worked for me. And usually I had a large research group of about 10, 15 people. And I'd get about 30, 40 postcards. And each city, I'd write the names and everything. I should have put stickers, but I thought it looked more personal. And I had time to kill in the evening sometime. I'd mail them. And in one city, I'd write to the person, dear so-and-so, having a great time, wish you were here, and sign my name, send it out. Another city, I'd write, same person, having a great time, glad you're not here. If I hadn't put their right street address, they'd never get the postcards. They always did. Well, organic chemistry is no different. And step 5, the main chain is numbered in such a way that the first substituent alkyl group counted along the chain receives the lowest possible number. Each substituent is located by its name and a number to the carbon it's attached to it. I won't get to it today, but when 2 or more are identical, I'll do this on Wednesday. But anyways, let's look at this. What does that mean? If we look at the methyl group here, what's the street address? What carbon is it on? Well, if I start from this end, it's on carbon 3. 1, 2, 3. If I start from the other end, this is 1, 2, 3, 4, 5. Now, IUPAC rules are you give it the lowest number. Which is lower? High level mass goes 3 or 5. I hope we all pick 3. So we tell what carbon the methyl group CH3 is on the longest chain by using this number 3. Now, common mistake is students want to call this 1. No, when you're numbering, you always have to start from the ends of a chain, the longest chain, never the middle or anywhere else. It can only be the end. So let's go through and quickly, longest chain, 7, heptane. Everything in the red box is spoken for. The alkyl group, CH3, from that chart is methyl. And what carbon is it on? Starting from this side, 1, 2, 3, so that's 3-methyl heptane. Oh my goodness, since I only did 5-minute breaks, we're out of time. Time flies when you're having fun with organic chemistry. I hope it is for you and Dr. White. Remember, we'll have class on Wednesday starting at 1 p.m., same Zoom login. Also tonight, I will have my office hours. If you have any questions from 5 to 6:15, come on by, say hello. It's a different login that's in the syllabus. Now, important thing I need to teach you about me. All my grandparents came from Russia, and my religion is Jewish. That's my religion. Jewish people who lived in Eastern Europe And Germany, back when my grandparents were there and for many years after, spoke what's called Yiddish. Yiddish is a mixture of German and Hebrew. My grandparents spoke Yiddish. I'm pretty rusty, but I know enough. And one of the greatest women I've ever met in my life was my mother's mother, Grandma Greenman, Bessie Greenman. What a woman. What a woman. Anyways, when I was young and even when I was older, we'd go over and visit her. And when we were leaving, she'd always use the Yiddish phrase, gehen gesund. Gehen gesund means go with health or be healthy. And since the pandemic, I've always ended every lecture, every lab with the following. Gehen gesund. I'll see you. I also stole this from the Beverly Hillbillies TV show, Granny. Goodbye, I'm done. Gehen gesund. I'll see you on Wednesday. And you can run away.